Welcome back to linear algebra. To begin with, we'll jump off an Anki. Just one flashcard too. What are elementary row operations on a matrix? What are the? You can multiply a row through by a non-zero constant. You can interchange two rows, and you can add a constant times a row to another row. Good. All right. So then we're going to grade what I did yesterday, and then I'll be back to report back how I did. All right, guys. So as far as the problems go, 43A, good work. 49, however. So this is when I was like trying to figure out which side to go on. I don't know why I thought of that. Like, it's classic like algebra and algebraic manipulation. What you do to one side, you've got to do the other. And since matrix multiplication is not commutative, surely you got to put on, if you do it to one side on the left, you got to do it to the other side on the left. So I went ahead and once I noticed that right away, I was like forced, and I went ahead and redid it and got the right answer. So nice. Now I'm going to finish up doing this theorem. I'll check it tomorrow with ChatGPT, and then I'll continue doing more problems after I finish it. So that's it for right now. I'll talk to you in a little bit. So funny enough, we went back and did another problem after we completed this proof, which is 2 pages, probably not that well structured, probably a lot of unnecessary words and fluff and stuff, but we'll have ChatGPT check it. I think it should be valid. And we did another proof, funny enough, from 1.3 this time. If A, B, and BA are both defined, then A, B, and BA are square matrices. So basically I'm saying, since they're defined, right, we know that for AB, the number of columns of A is going to equal the number of rows in B, and for BA, the number of columns in B is going to equal the number of rows in A. And then since this, we'll say number of columns, we're just rewriting this, number of columns of A equals number of rows of B. So we'll denote that as, say, N. And then say number of columns of B, we already denoted that, we already said that, we're denoting it now, equals the number of rows of A. So let's denote that as M. So A mxn times B nxm equals AB mxm. And B nxm times A mxn equals BA nxn. So we know that since these are, the rows and columns are equal, then they're both square matrices. And I didn't really say since the rows are the same as the columns, it's a square matrix. That's kind of a given. I think it's a little unnecessary to state. So for the theorem, another one we did was proving that A plus B equals B plus A. That is if they're the same size. So if A and B are matrices the same size, then the number of rows and the number of columns in A are equal to the number of rows and number of columns in B. Let's denote it mxn equals mxn. If A and B are the same size, then we can add them together and get a defined result. That's just by definition of matrix addition. If we add 2 matrices together and the answer is defined, then the entries of the resulting matrix will each be the sum of the corresponding 2 entries from the original matrices. Algebraically, we can represent this, A plus B equals C. And here's A, here's B, and then C. And then we do it for the other way. We say B plus A equals D. And I didn't write out all A, B, and A again, but I just denoted D, ending up as this, which equals C from earlier, because both matrices are the same size, and each corresponding entry is equal by the associative law of addition. Therefore, A plus B equals B times A. I think it's fine. I mean, for having literally as much training in proofs as I've watched one video on how to do proofs, I think they're all right. Proofs are getting a little less scary. That is, I mean, we'll see. We'll see tomorrow what ChatGPT grades it as. So, or not grades it, but it says if they're good or valid or not. So for second and third proof I've ever done, I'm kind of happy. I mean, at least I proved it to myself. Like I mean, these proofs proved it to me. I was like, if A and B and B are if A, B, and BA are both defined, then prove that A, B, and BA are square matrices. I'm like, but I just did it. So that's cool. I mean, this is a really cool skill. So that's it for today. Talk to you tomorrow. See you.